operated through humanoid robots.
Humanoid robots?
Humanoid robots
For the first time,
have been used to perform surgery.
procedure on live pigs.
A few weeks ago, researchers demonstrated something that once belonged to science fiction. A humanoid robot performing surgery. It worked. So here's the question. Would you trust it? My name is Tiffany Bao. I am Associate Professor from Arizona State University and Special Faculty at Carnegie Mellon University. My team will give you an answer. Let's simulate a surgery scenario. Dr. Robot is operating on his patient, Mr. Giraffe. Effortless, trust him simple. The robot moves smoothly, it follows commands, it never shakes, it never gets tired. But none of those things is actually why we trust it. This robot didn't become unsafe because it forgot how to move. It became unsafe because an attacker controlled it. Someone who's never touched a robot. When security is compromised, the attacker gains control, in this case, the commanded robot to stop working. Software offers commands to make the robot exert force, and security determines who's allowed to send the command. Here's something interesting. This wasn't some brand new security hole or what we normally call a zero-day vulnerability. Every individual vulnerability was already known. The challenge wasn't discovering them. It's understanding how several known vulnerabilities could be chained together and turn a digital weakness into a physical consequence. And when the machine is a humanoid robot, that changes the stakes completely. A vulnerability in a web server might leak your data, but a vulnerability in a humanoid? That can change how the machine moves in the real world. A hack signal can become an unauthenticated command. An unauthenticated command can become an unintended movement. And when that robot is working next to people, one wrong movement could make it fail its task, damage something, or even hurt someone. And the weakness might not exist in just one place. It could be in the network, the software, the AI models, its control system, or the way all of those parts interact. An attacker can combine subtle weaknesses across the entire chain into a cyber attack becomes a physical event. That's why humanoid security isn't just a cybersecurity problem. It's a robotics problem, an AI problem, a control problem, a human safety problem. No single field can solve it alone. Before we trust a car with our family, we test and certify it. Before we trust an airplane with hundreds of passengers, we test and certify it. Before we trust a medical device that reaches a patient, we test and certify it. Go back to the 3 vulnerabilities. Every vulnerability was already publicly known, and individually, none of them told the full story. But when we combined them, the robot entered zero torque mode. Today, we usually identify and score vulnerabilities one at a time, but attackers don't have to use them one at a time. So, testing a humanoid cannot mean checking vulnerabilities one by one. The test must also capture how multiple vulnerabilities interact and what those interactions make the robot jeopardize safety. That means turning known vulnerabilities into realistic, repeatable attack scenarios. Scenarios when we ask, what happens to the robot? What happens to the task? And most importantly, what happens to the people around it? But building those tasks require the knowledge of vulnerabilities and how the entire robot works. And right now, the knowledge is scattered. Manufacturers understand the robot's internal systems. Robotics and safety engineers understand how the machine will behave safely. Security researchers may discover some vulnerabilities. Each of them holds one piece of the puzzle. But if they work separately, no one sees the full picture. We need an ecosystem where manufacturers, security researchers, roboticists, and safety experts can responsibly share what they know. Not just which vulnerabilities exist, but how those vulnerabilities can be combined, what physical consequences they can produce, and how the robot should respond and recover. That's also why programs like bounties can be so valuable. Not simply because they collect more vulnerabilities, but because they connect the people who discover vulnerabilities with the people who understand the robot. Together, they can turn real vulnerability knowledge into realistic attack tests. Those tests can provide evidence. That evidence can support safety standards and eventually certification. This video wasn't about a robot, a manufacturer, or some particular vulnerabilities. And in fact, the manufacturer we're demoing today is a pioneer in building up a bug bounty program. It was about a question that our industry still doesn't have a complete answer to. How do we know a humanoid is trustworthy? We don't have all the answers yet, but answering that question will require cybersecurity researchers, roboticists, AI engineers, manufacturers, and safety experts working together, because trust isn't assumed, it's testified.